The last examples we're going to look at are limits at infinity, but particular cases in which there is a radical involved. Otherwise, we are going to start the same way in that we divide through by the largest power of the variable. So if you take a look at what we have here, the largest power of the variable would be x squared. So we would divide through by x squared. Now let me start in the denominator for a particular reason. So I'm going to divide here by x squared. In the numerator, though, when I come outside of that radical, you need to consider what you're really now doing is square root of x squared, because you're coming outside of that radical. Square root of x squared is going to be x. Now the reason we go with a positive x is because we're doing the limit as x is approaching positive infinity. So up in the numerator, what we're going to divide through by is positive x. Otherwise, we pretty much do it the same exact way that we were doing it before. So we're going to simplify where we can. So this simplifies to 1. And these cancel. Don't forget you still have your 6 there. Now you do have some little fractions which are going to approach 0. So let's just rewrite what we have. And since our variables have essentially been eliminated, we can omit the limit notation at this point. Up in the numerator, we have 0 minus 1. In the denominator, we have square root of 0 plus 6, which gives us negative 1 over square root of 6, and that would be our answer. Now you can check these graphically as well. You can go ahead and graph that function. What you're going to notice is that at the far right extremes of your graph, you're going to notice the graph kind of leveling off, and where it's leveling it off at is at the y value of negative 1 over root 6. If you were to hit trace on your calculator, you'll notice that decimal equivalent of negative 1 over root 6 is approximately negative 0.408. So give that a try and you'll see how it works out. Otherwise, let's take a look at one more example. Now this time we're doing the limit as x approaches negative infinity. Otherwise, we start out the same way in that we divide through by the largest power of the variable, which in this case is going to be x squared again. So up in the numerator, we're going to divide through by x squared. Now when we come outside that square root, this is now where you have to consider you're approaching negative infinity. So now we're talking negative numbers. So if we're doing the square root of x squared, we're going to think of that as being the negative square root. All because, again, we are approaching negative infinity and dealing with negative numbers. So in the denominator, we're going to be dividing through by negative x. Otherwise, let's just simplify where we can. So these cancel. That just leaves a 5. These cancel. So that leaves us with a negative 1. We do have some little fractions that are going to zero out. So let's see what we have remaining. Up in the numerator, we have square root of 5 minus 0. In the denominator, we have negative 1 plus 0. So that leaves us with a negative square root of 5. Once again, you could graph this expression. Take a look now at what happens at the far left extremes of your graph. And you'll notice that it's leveling off. Your curve is leveling off at a y value of about negative root 5. The decimal equivalent of that, if you want to see if you're getting the right thing, is about negative 2.236.